As always, you will find a complete description of the model that we use in this lab in the lab document. And also you will find the lab outline. Let's talk about the assignments for this lab. So the assignments for this lab consists of two parts. In the first assignment, you are asked to watch the fourth module of the Learning Simio Lab series developed by Dr. Jeffrey Smith. You can find the link to the video module on the lab document. So this video lab involves different topics related to Simio animation. It also has an assignment portion where you are required to develop a Simio model of a system of your choice. So it can be a medical clinic, it can be a restaurant, it can be a manufacturing system, or any other type of system of your choice. The deliverables for this part of the assignment is kind of different. For this problem, you will need to make a video of your animated model. The maximum length of the video is 1 minute, so you should limit yourself to 1 minute. So in your video, you need to show your model, the different animation components of your model as the model is running in both 2D and 3D modes. So be creative, rotate, zoom in, zoom out, and use other tools that are available to you to show different animation features of your model. So you can either provide the video file in your submission zip file or provide the link to the video in your report document. Also, note that your work will be evaluated not only based on the animation features that you use in your model, but also based on the quality of the video that you make. In the second part of the assignment for this lab, you are going to start with the model of the Subway restaurant that we developed in video 3 of this lab. So that's the model with the rate table and work schedules. And the objective here is to find potential good schedules that would result in the maximum number in system being less than 10 customers. So note that we would like to achieve this objective using reasonable capacity allocations. In other words, we're looking for cheap capacity allocations. Base your analysis on 50 replications for each scenario. And I have provided a hint here in the lab document as to how you can approach this problem. So as the hint says, basically what you need to do is to evaluate different possible work schedules to see which ones will meet the requirement that is specified, which is the maximum number in system being less than 10. So you need to develop work schedules not only for your bread and veggies station, but also for other stations if necessary. And you need to perform experiments. So you need to run experiments and replicate your model for different work schedules. Now, in order to facilitate experimentation, you can use what you learned in Lab 5, which was on reference properties, and actually use reference properties to define different work schedules right in your experiment table. And also you can define a response for the maximum number in system to be able to compare different scenarios or work schedules. For the deliverables, you should provide screenshots of the work schedules and the reference properties in them, and also your experiment table with different scenarios and the results of your simulation runs. So let me actually go back to this model and show you how you can do this problem. So first of all, make sure that you're not using the arrival table, so that when you're replicating your model, you're not basically using the same arrival pattern. So what I need is to go back to my arrival rate table. So now I'm using my rate table instead of my arrival table. Here is my rate table right here. So what I can do is define referenced properties, I'm going to go to definitions for my model and properties, and let's say I would like to define a reference property for the capacity of veggies station. So veggies capacity between 6 to 8 p.m. So I'm going to call it veggies cap 6 to 8. And I'm going to give it a default value of, let's say, 2. So now when I go to my work schedule, day pattern, here's my work schedule. So what I can do is I can change, instead of having the value in my work schedule for the 6 to 8 p.m. Item, I can change this and use my referenced property. So I named my reference property veggies cap 6 to 8. So now when I create a new experiment, this value will appear as a control. My reference property will appear as a control in my experiment. So if I want to have 3 units of capacity, I can simply change this value in my experiment table to 3. Now what I've essentially done is changing my work schedule so that I have 3 units of capacity at Veggie Station from 6 to 8. You probably need multiple day patterns for different servers. So make sure you adjust your work schedules in your servers accordingly. And as always, if you're working on this lab as part of a course assignment, please make sure that you follow the submission requirements that are provided at the end of the lab document.